Hello and welcome back. We're going to continue on our topic of cell injury. All right. Now, in the previous video, I had a number of different things that can cause cell injury, but the two that we are going to focus on for this course are going to be ischemia and hypoxia. Okay? Now, both of these are going to be due to a lack of something. Ischemia is a lack of blood flow. So for one reason or another, a tissue or a cell is not getting blood coming to it. It's not getting nutrients. If it's not getting nutrients, it's not getting oxygen. All right? Hypoxia is going to be due to a lack of oxygen. Now, ischemia can result in hypoxia, but hypoxia doesn't always have to be due to ischemia. An example of that is carbon monoxide poisoning, because that carbon monoxide binds to hemoglobin and doesn't let go. If you remember from your A&P, all right, with hemoglobin, the carbon dioxide and oxygen binding and being carried in the hemoglobin or in the red blood cell is a reversible reaction. More specifically, the oxygen really, okay? So what the carbon monoxide does is it ends up taking the spot where the oxygen might bind, and it doesn't let go. So you've got plenty of red blood cells, you've got plenty of blood flowing to the tissue, but you still have a lack of oxygen because the carbon monoxide is taking the place of where the oxygen would normally go, okay? And what ends up happening with ischemia or hypoxia, you end up inducing damage. All right? And that's what we're going to focus on. All right? I do want to mention real quick, there is some tissue variation as far as the amount or time that the tissue can be without oxygen. The key one is the brain. The brain is very needy. So you're looking at about 3 minutes, all right, before the lack of oxygen becomes an irreversible, results in damage that's irreversible, okay? Other tissues, just for comparison, something like the kidney can go a little bit longer. I think it's in the range of 15 to 20 minutes before the damage happens. So the amount of ischemia, the amount of hypoxia is going to depend on tissue. Brain, that's the one we want to watch out for because that's the most sensitive, okay? So just keep that in mind, all right? So with ischemia and hypoxia, all right? Ischemia in particular can lead to what's known as a reperfusion injury, okay? Because with ischemia, you've got a slowing or a reduction of blood flow to a particular tissue, all right? When that blood flow is restored, what can happen is that you can have a calcium overload that happens within the cell due to now the increased blood flow. All right? That calcium overload can lead to free radicals. Those free radicals then can cause cellular damage. Okay? So even though the blood flow is restored, there can be additional injury that happens due to the increase in blood flow to the region. Okay? So if a particular cell is not killed or injured due to the lack of blood flow, this is what we would refer to as a secondary condition. You can have the cell either die or be injured from the return of blood flow, because what ends up happening, the calcium that's normally been sequestered within the cell becomes available, all right, within the cell. And it's available in a place where it's not normally supposed to be at a time it's not supposed to be. That's what leads to the free radicals. Those free radicals essentially are like electrons traveling around that are looking for things to attach to. When they attach to things, that's when they cause damage. Okay? So that's part of it. The other thing that can happen, in addition to the free radicals, you can have activations of various enzymes. Okay? And I'm not going to go into the specifics with the names of the different types of enzymes, but what those enzymes can do is cause damage to cell membranes. All right? And that's another place where reperfusion injuries can result in the death of the cell, because if you break open the cell membrane, that cell spills its contents, all right? And that is what results in the death of the cell, okay? If you get the cell contents to be spilled, this is going to trigger an inflammatory response. And we'll talk a little bit and review the inflammatory response in another video. Inflammation in and of itself can be a way to resolve injury. If it continues long term, it can actually start damaging surrounding tissues. So in this case, spilling the contents of an individual cell would be something that would be a normal inflammatory response. But bringing in those white blood cells, that potentially then can also trigger injury, all right? But that injury only happens if the inflammation is chronic, all right? If it's an acute response, that tends to fall into the normal inflammatory response, okay? So with our injury, all right, our injury can be acute, so it's going to be a very short-term response. In the case of the short-term response, typically the cell is going to recover, okay? Unless you're talking about something more catastrophic like losing the cell membranes, all right? You can then have a persistent response. That persistent response results in an adaptation on the part of the cell. And my next video, I'll go over what some of the adaptations are. All right? If it's prolonged or chronic, that's when we lead to our irreversible injury, okay? So the acute, the persistent, these can be reversible in most cases, all right? But if you've got a prolonged response, that ends up being an irreversible type of injury, okay? And I'm just going to kind of introduce now, because we want to focus on the reversible injuries right now. Our two types of reversible injury are going to be hydropic swelling and oh, that's not right. There's no B right there. Intracellular accumulations. Okay? So the next video, I'll kind of go over those reversible injuries, the hydropic swelling. This one, hydropic, when you've got hydro in there, you want to think water. Somehow you've got water that comes out of balance. Okay? The intracellular accumulations, there can be a number of different accumulations. Some of them are things that are normally made by the cell, or it can be something external to the cell. Okay? But I'll kind of wrap up this video here. Next one, we'll delve a little bit more into reversible injuries, the hydropic swelling and intracellular accumulations. Thank you for your time.